Today we have the fractional change in length produced in an elastic material of spring constant 680 Newton per meter when a force of 306 Newton is applied to stretch it is 1.5. We have to calculate the original length of the material. Now the question is coming from elasticity. They mention at least three things here. Let's say four. They say that the spring constant of that elastic material is 680 Newton per meter. Let's write it. Now, you should know that, remember Hooke's law, that K is equals F all over what? E, from Hooke's law. So they told us that the force constant, that's what they call spring constant, is 680 Newton per meter. When a force of 306 Newton, now the force involved is actually 306 Newton, is applied to stretch it. Now, they say that the fractional change in length. Now, let me ask you a little bit. If my height, watch out, if my height is, let's measure in feet. If I'm 2 or let's say 5 feet tall, and let's say in the next 5 years, I become 10 feet tall, what will be the fractional change in length? The fractional change in length should be, first of all, you have to calculate what's the change. It should be 10 minus 5. But since the word fraction comes in here, it should be the change all over the original height. Now, I don't know if you understand me. If I said if, and as in this question, we have the original length, which we call L1, and the new length, which we call L2. Now, if the length was given a certain value and the length later increased, that's the new length, we later had the new length. Now, what will be the fractional change in length? The formula will be, what will be the change? The change in length will be the new length minus the original length all over. You want to get the fractional change, it will be what? All over what? The what? Original length. Does it make sense? All over the original length. So I have the fractional change in length. Last, they say that it is 1.5. So in this question, we have that L2 minus L1 over L1 is 1.5. Does it make sense? So from here, and I know that the formula of extension is actually, if you want to get the extension, is actually the new length minus what? Original what? Length. Does it make sense? So I'm having force constant, which is 680, is equals the force 306 all over the extension, which is L2 minus L1. Now, since I'm having these and I'm having two unknowns, how can I get something? How can I get the original length? It's not possible, right? But don't forget that we have something like this. That fractional change in length is this, right? Now, if I cross multiply here, what am I going to have? This times this will give me L2 minus L1, because all this times 1 is still the same thing, is equals 1.5 times L1 is actually 1.5 L1. So whenever I see L2 minus L1, I have to take it as 1.5 L1. So watch out what I'm having here. So I'm having 680 is equals 306 all over 1.5 L1. Now what am I going to do next? I have to cross multiply. 306 times 1 is 306 is equals, now what is 680 times 1.5 L1? So making use of my calculator, if I have 680 times 1.5 will give me what? Times 1.5, it will give me 1020. Now don't forget the L1. So this times this will give me 1020 L1. So what am I going to do next? I have to divide both sides by the coefficient of L1. That's all over 1020 all over 1020. Cancel, cancel. So finally, I have that L1 is equals 306 divided by 1020. 306 divided by 1020. That will give me 0.3 meter. And that's the answer. Now, if you want to change it to centimeter, it's actually 30 centimeter. I hope you understand. Have a nice day. Like, comment, share, and follow Kosis Academy. Bye-bye.